Hello wonderful person, this is Anton, and today we're going to discuss some of the more recent studies in regards to the hypothetical Dyson spheres. Those hypothetical megastructures that some kind of an advanced civilization might build to harvest the energy of a star. But in this video, we're actually going to be discussing some of the recent studies, focusing on several candidates that have been previously discussed in some of the videos in the description, because those stars actually possessed somewhat unusual infrared signatures that have been previously linked to a hypothetical Dyson sphere. But these strange stars with their bizarre emissions are still most likely to be just stars. And so basically don't get too excited because there are still a lot of natural phenomena we just don't understand. And so in this video we're going to discuss several peer-reviewed articles that focus directly on some of this evidence from the James Webb Space Telescope and investigate some of these top candidates. And so here this study on Project Hephaestus, as well as this one and this one, is kind of worth discussing because they do focus on slightly different phenomena and do make slightly different propositions. But I guess first let's discuss the basics and exactly what was discovered. And I guess let's start with the basic premise, which here is pretty simple. And so back in the 1960s, Freeman Dyson popularized this somewhat intriguing concept that he actually technically borrowed from the fiction book called Star Maker. And so here, as a civilization grows and as it reaches higher and higher demands, specifically energy demands, I guess kind of like what we're experiencing right now with this tremendous boom in the AI industry, at some point the energy needs become so high that the civilization eventually starts to harvest something outside of the planet. And in order to solve this energy requirement, it basically starts to rely on a swarm of satellites orbiting the star itself, the so-called Dyson swarm, that starts to directly capture the light and transmit it as energy to the location where it's needed. But physics also tells us that you cannot just create energy without creating some kind of an additional waste heat. I mean, I guess you could if you're some kind of a super advanced civilization, but here for the sake of argument, we're going to assume that they're not that advanced yet. And this waste heat is actually going to glow in mid-infrared light that should be visible around the star, and that can then serve as a kind of a technosignature, allowing us to hypothetically detect them if we find a star with these very specific infrared emissions. Or at least that was the main proposition in a somewhat recent project referred to as Project Hephaestus. The project that you can learn about in the link in the description. And the main premise was pretty simple, using several surveys conducted in the last few years in order to search at least 5 million separate stars and analyze their emissions using Gaia telescope and WISE satellites. And specifically, the search was focusing on stars that appear to be much brighter in the infrared compared to what's expected. And out of 5 million stars, at least 7 of them were discovered to be somewhat unusual. So basically here we had 7 intriguing M-dwarf stars, or your typical small red dwarfs, that seem to show significant infrared excess. Way more than expected from a typical star of a similar size and similar age. And this was of course super exciting when it was initially announced a few years back. But, as Carl Sagan once said, extraordinary claims require extraordinary evidence, and that extraordinary evidence had to have come from the best infrared telescope we currently have, the James Webb. And so here astronomers decided to take a closer look in order to find out what's actually here, and if these stars are indeed producing these unusual emissions. Well, in this case, out of 7 candidates, they decided to just take 2, Candidate D and Candidate E. And the idea was to basically analyze their infrared emissions in order to compare them to what we already know, and in order to find out if this can indeed be the result of some kind of a swarm emission indicating an artificial structure. But in this case, the results were a great example of how our universe can sometimes be a bit of a trickster. And that's because there was a case of a photobomb. And so here, by using the extremely high-resolution observations from JWST, researchers revealed that the bizarre emissions were not coming from the stars themselves, and instead from something that was extremely close in terms of space, but was actually much farther away beyond our galaxy. The stars here were being photobombed by an extremely distant object, specifically a distant galaxy, sitting almost perfectly behind them from our perspective. and in this case galaxies that are known to be quite intriguing and quite exciting. So for example, the candidate D turned out to be hiding what's known as a hot dog, hot dust-obscured galaxy, which represents a rare type of a galaxy where a supermassive black hole is actually heating up massive clouds of dust, making most of the galaxy practically invisible, and instead producing huge amounts of infrared. In the last few years, we've actually discovered quite a few of them, and they are quite rare and quite exciting. But they're essentially powered by these tremendously powerful central black holes that accrete a lot of material at a very rapid rate, releasing vast amounts of energy and creating so much radiation that it then heats up a huge cocoon of dust and gas around the galaxy, re-emitting it mostly as infrared, making these objects appear thousands of times brighter than a typical galaxy when observed by infrared telescopes. And well, in this case they represent galaxies with disproportionately enormous black holes compared to normal galaxies, with the most luminous such object, referred to as W2246-0526, producing something like 350 trillion solar luminosities, making it the brightest such object in the infrared. And naturally these objects, because they're so bright, from a distance resemble typical stars. And so in this case, one of these galaxies seems to be right behind a regular M-type star, with the candidate E sitting in front of a slightly different dusty starburst galaxy that's also producing a lot of infrared because the stars here are forming at an incredible rate. So not as bright in terms of infrared emissions, but still bright enough to appear as a kind of an anomaly. And one of the main reasons they were first misidentified was basically because the older WISE telescope could not see them very well and had relatively blurry resolution. Or basically it saw both the star and the galaxy as a single object. And so they were actually even classified as a single object, with the galaxy remaining invisible until now. But here the observations from the James Webb showed us that when you look at much longer wavelengths, the star actually fades while the background galaxy lights up and becomes extremely easily visible. And so in these two candidates, while we did not find any kind of extraterrestrial intelligence or super advanced aliens, we did discover two extremely interesting galaxies that we might have never studied otherwise, with one of them being super rare. With that hot dog galaxy possibly even taking us closer to answering some other mysteries, such as the mysteries of little red dots. The concept you can learn about in one of the videos in the description. But even though no Dyson spheres have been discovered here, there actually have been some other intriguing propositions in the last few months. And specifically in this new study by Sahin Turlakic, we have a slightly different concept referred to as stellar J harvesting, or basically the idea of collecting energy from the star, but that actually might be slightly more difficult to detect. And the concept here is also pretty easy. What would be the easiest way to capture energy from a star if we wanted to avoid building a Dyson sphere but still wanted to collect something? Well, technically you can also capture the star's spin, which requires much less material and can still capture a lot of energy. And well, the thing is, while most Dyson spheres focus on capturing luminosity or the light from the star, here this concept captures the star's rotational angular momentum. And in this case it does so without producing any waste heat. And well, in order to do this, some kind of a civilization might use a magnetic tether embedded in a solar wind or even a massive orbital flywheel that uses electromagnetic forces to break the star's rotation, with this angular momentum then basically converted into direct energy. In some sense, I guess it's kind of similar to a windmill or something, except that instead of a windmill, you're basically using the rotation of a star. And if a civilization were doing this for millions of years, the star here would end up with extremely slow rotation velocity compared to similar stars of the same age and the same type. At the same time, this would actually benefit the alien species because a slow spinning star does not produce as many magnetic emissions and thus does not produce as many solar flares, basically making the star system just a little bit safer. And well, the thing is, the author from the study decided to once again take a look at maybe some stars out there that could have anomalous rotation compared to their age. And he seems to have discovered two. You can see their names right here. And so these two stars rotate every 61 and 65 days, which for G-type stars, or basically stars like our Sun, seems to be just a little bit too slow. We actually expect these stars to spin once every 5 to 10 days. In other words, at least at the first glance, these are definitely two anomalous stars. But once again, we have to be just a little bit more skeptical, because these are obviously just candidates. And because their slow spin can also be explained by natural factors, like for example, low metal content, or maybe some kind of an unseen binary companion breaking the star. Nevertheless, a really exciting concept, and something we'll come back to and discuss more once there are some additional follow-ups. And last but not least, we also actually had a somewhat interesting workshop at the MIT. Or essentially here we had a kind of a expert discussion about the Dyson spheres around black holes. And this was literally called Dyson Minds 2025. And so while we often think of black holes as something extremely destructive and something that doesn't actually like to have things around them, they do actually emit massive amounts of energy through the accretion disk and through the jets. And technically, if an advanced civilization reached level 3 on Kardashev scale, essentially being able to use energy from the entire galaxy, they might naturally gravitate toward a galactic center in order to harvest the most powerful source in a galaxy, the central supermassive black hole. And theoretically, they could even place data centers approximately 3 light-years away from the black hole itself. Here we're talking about your typical AI data center, of course. At this distance, they would be far enough to be safe and would not melt from the heat, while still being able to harvest immense amount of energy. And so here, hypothetically, you can also use the central black hole as a source of tremendous amount of energy for an extremely long time, with astronomers now looking at the data from the Event Horizon Telescope in order to see if there are any unusual blips or perturbations that could maybe suggest some kind of an artificial structure in the center of our own galaxy, or the galaxy M87. Once again, this is a super hypothetical proposition, and just something that scientists wanted to, I guess, discuss because it does sound kind of fun. But in the end, what we've learned so far based on all of these studies is that sometimes anomalous objects, instead of being aliens, actually turn out to be really strange galactic objects that we actually only recently started to discover. Specifically, a lot of these dust-shrouded galaxies that seem to mimic signals from a lot of hypothetical alien technology. And so in some sense, the search for extraterrestrial intelligence is technically driving us to discover additional phenomena that sometimes we never even knew existed and are only learning about right now. In most cases, these end up being interesting astrophysical phenomena that one day will teach us so much more about the universe itself. And so that question of, could it be aliens, so far resulted in a negative answer, but in positive scientific discoveries. And so even though the silence of the Fermi paradox continues, our tools, technologies, and techniques are improving every single year. And so once scientists analyze additional candidates, or once we hear more about these two strange stars, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else. Support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.